Hello, everybody. What we're going to do today is walk through kind of the steps and code that you need to write some C++ code to connect to a remote service. So we're writing a client that connects to some server. One thing that I'd like to point out is that man pages are your friend. If you ever hear of a function or something that you don't know much about, then you should man that function on your Linux server. Or you can go to kind of these Linux man pages that exist out here in the wild, which are fantastic. One of the things that I'm going to talk to you about today is called gethostbyname. Gethostbyname is deprecated, and it has some newer features, and you can find that in the man pages, which is super fantastic. So what are the steps we need in order to connect some client to a remote server? I've kind of laid them out here. These are loose steps, but there aren't really that many for the client. It's pretty straightforward. First thing you need is to figure out where you're connecting. So your connection to a remote machine has to do with the IP of the machine, the address of that machine, plus a port, which is kind of which program on that machine do I want to connect to. We're going to focus on connecting to a web service, which is typically on port 80, although it does not have to be. And so we're gonna work on that, and we're going to translate host names into IP addresses using the domain name system, like we talked about in a previous video. So the first thing we have to do is get our host IP. We have to know which port we want to connect to, and then we take all that information, we stick it in this sock address structure. Once we have that, we ask the OS for a socket, and a socket is basically this item. Let's call it a box. It's a box that the OS and the network know where to stick your information. So when you make a connection as the client to somewhere else, you connect through it using a socket. And so when information comes to your network card, it will look and see that certain packets of information are destined for this particular program, and it will dump them in the socket for you to kind of interact with. So the first thing we need to do is get this socket address structure. The second thing we're going to do is make a socket. The third thing that we're going to do is connect to the remote service using connect function call. And then after that, you can send and receive over the socket that's been connected. And so that's our general kind of 4-step process. Pretty straightforward. Nothing too scary there. One thing to be aware of is in systems programming, oftentimes a 0 return means that things are good, and a non-zero return means things are bad. And that's maybe the opposite of what you might expect. That is true in a lot of systems programming, but a lot of the function calls that we're going to work with do things a little bit differently. All right, so go ahead, let's jump into our code. What our code's going to do is it's going to take let's go ahead and look at it. It's going to take a host name like google.com from the command line as one of the first arguments, and then the second argument is going to be a port number. But you remember in C++, the command line arguments come in as character strings, and we need this port number as an integer. So we're going to use this tool called A2I that turns character arrays into integers, and we'll pass this port number character string that we get from the command line arguments, and we'll get an integer out of that. Okay. This assumes the user is doing the right thing, and I haven't put any checks in here, so I'm just kind of giving you the basics. The second thing we're going to do is take this host name that we got, like google.com. We are going to ask for its IP address. So we're basically going to say, hey, DNS, can you tell me what the IP address is of this host name? And so DNS is going to give that to us, and it's going to stick it in this special structure, which is this host entry structure. If we don't get one of those, then it means our DNS couldn't resolve and we have problems. One function that we like to use for this sort of thing is perr. Perr will print whatever the last kind of worded message of a failed system call might be. So if this fails, perr will tell us why, and it will also spit out couldn't get a host name. I'm returning 1 here. Another thing you might do is exit. This is all inside main, so a return 1 will exit my program. Okay, so let's move down and see what some other things that you might do are. If you would like to know the IP address that you got from this get host by name, I left some code in here. This is an inet underscore N2P. So what we're trying to do is take this network structure and get some character array out of it. You can also go the other way around. For example, if you had the IP address and you needed a byte version, there are function calls to do that for you. And that's what this inet p2in is down here. But we're not using that this time around. This time around, we're taking in the like google.com address and a port number, port 80 for the web server. And we're kind of getting them into these structures. In this case, we're getting it into this hostent, and we're getting the integer port number. Okay, then what we do is, like we said in step 1, let me move step 1 over here a little bit. We're going to push all this stuff into this sock address in, right? And so we're going to zero the whole thing out, label which kind of connection we're going to make, in this case, AFI_INET, and then we're going to copy out of the host int into this sock address, the host information that we need. And then we're also going to copy this port number into that same sock adder in address. After that, we have all the pieces we need to make the socket, make the connection. Making the socket is pretty straightforward. There are some other parameters we could use here if we wanted to specify which IP address or which network card almost that we want to actually listen to. But for the most part, we don't care. We just want to take anything destined for this socket once the connection is made, and we don't have to do anything specific here. So then what? Then we make the connection. So to make the connection, you have to pass in the socket. The socket is going to get passed in every system call from here on out because we're interacting over the socket. I have to pass in kind of where I want to make the connection to. And so you can see that I'm doing that here. There is some weird archaic mumbo jumbo going on here. What I'm doing is I'm getting the address of the A2 object, and then I'm casting this whole thing into a sock adder pointer. If you don't know what any of that stuff is, then don't worry about it too much, and just know that you have to kind of attach this in front of the A2 in the connect function call. And then I have to tell it how big this thing is so that it doesn't walk off the end of it. And you'll see here, I ask if the result is less than 0. In this case, less than 0 is giving us a bad connection. And so I do a P error connect. And then there's nothing else in my code, so it just breaks out. Otherwise, if I get inside this else statement, then I've connected successfully. This is a special character string, which basically says, get me the index.html using this protocol at this host. And this is a proper HTTP request for the index.html of some remote host. You might consider kind of piecing this together with the host that was passed into the first character argument. I didn't do that here, so really my program is probably only going to work for Google, because anybody else asking for index.html from google.com, their web server is probably going to tell you, I don't know what to do with that. That doesn't make a lot of sense. And then what I'm going to do is I'm going to send over that socket this buffer. I want to send this many bytes, which is the length of the buffer, and just send this whole thing. And if that is less than 0, then that means there's an error. So I send some issues here. And then I wrote a function for receiving messages, which receives messages in bunches of 128 bytes. And so I passed this buff2. I made the buff2 256 to give myself plenty of overflow room. You don't need that. I could have made it 129. I want one more than I asked for here because of the way I do things in this receive message. And so what I'm doing in this receive message is basically like, just keep receiving stuff until this function returns a 0. For the most part, that's just going to receive stuff forever. But let's go up and look what that function call looks like. You can probably guess that it looks a lot like this function call does, the send and receive being kind of duals of each other. But I've added a little bit of extra stuff in there. So let's go up there and look at this function. So I'm passing the socket, a buffer that I'm going to receive into, and how big I'm going to allow messages to come into that buffer. There is a used variable, and that used variable is going to tell me how many bytes I received when I do my receive call. And this is the receive call where you're actually interacting with the socket. You're saying, hey, socket, I want to receive from this socket into this buffer, and I have this many bytes left that I can actually use. And then it will tell me how many bytes it got from that socket. And as long as it's, non-zero, it's basically not an error. One thing that I do here is after I get how many bytes I received, I put this special character in there. And this has to do with how C strings work. This is a null terminating character for C strings. And so I just make sure that there is a 0 at the very end of any string that was received from this. And that's why I need one more byte than I could possibly receive. So I probably could pass 255 up there as long as I'm allowed to put this null character at 256 in case I receive that many messages. Anyway, and then I print it. Now, if you are doing a get command from a web server, there is a specific number of bytes that you get from the web server, and we're going to see that. You could see on failure, I return -1, and on success, I return 0. And so that while loop is just gonna like keep receiving these messages until it fails. But mostly it's just not gonna fail. So let's run it and see how it works. Remember Control C. Whoa. Remember Control C is how you kill a running application. Let's go ahead and compile it real quick. It was called get.cpp, so there's the compilation. Now, if I just run ./get, I protected myself from doing anything silly. But if I run ./get, google.com port 80. So this is me connecting to google.com's web server and asking for index.html. I hit go. You can see that it's sending this as the request. And then I hit the receive loop, and the receive just keeps receiving information until it fails. And you can see it hasn't failed yet. It's probably not going to fail. The way this should be done is I receive header information until I get to this kind of 229, and that 229 tells me how much the body size should be. That's like the payload size. And then I'll know exactly how many bytes to receive. And then after I receive that many bytes, I can stop here and kind of move on to my next request. And that's how your servers will work. That's how your websites will work. And so this is a little simple client that connects to any web server you want. Of course, if you're going to connect to different web servers, make sure you alter this code down here. And we could do this with strings. And I think there's a couple of important things maybe to show you here. If you are going to use C++ strings and you want to do something like, say, add that character string here instead of using google.com, you should be aware of some of the pitfalls, I guess. Let's give this a name. I haven't given it a name yet. I guess I'm calling it buff here. So I will continue to call it buff for a second. So then I want buff to be plus equals argv of 1, and that should work okay. And then let's go ahead and add in the returns, which kind of force things to happen. I guess since I'm using a string, I don't necessarily have to add this /0 here. So this might work. Okay, so what's the biggest differences here? The biggest differences are that these buffs are now strings, not C strings, so none of this is going to work. But the way that you turn a C++ string into a C string is you can add .c_str, and that will give you access to that underlying piece that you might need. Okay, so let's talk about pound includes. You got to make sure you do a bunch of pound includes for net stuff. You can see here I have pound include string.h. That is a little different than pound include string, which is the standard string. So let's go ahead and do that and see where we get. There we go. So now I can do google.com port 80. I get the same result, but I should be able to do a get on some other address, yahoo.com port 80. And I should be able to grab that index.html. So you can see here, it says the location is https yahoo.com, and that there isn't much content here because this particular address has been moved permanently. What else do we have? We have like a bing.com maybe. We can always do that. Content 0. This is strange. Moved permanently. So you can see a lot of these index.htmls are showing up in different locations. Maybe we can try www. Anyway, you get the idea. We can do a get on any web page, and it will report kind of what you get back from that web page. There's plenty of things that we could change here to make it a little bit better. But this is meant to kind of get you writing your first coded client more so than it's meant to kind of get you a working web client. But it's still fun. It can still be used to kind of debug some things. So maybe you'll find that useful. All right, we're running on 15 minutes, so I'm going to let you go. I'll see y'all next time. Take care of each other. Take care of yourselves. Bye.